Okay, looking at part 2 now, looking at question 25. Use the point slope formula to write an equation of a line passing through the point 6, 2 and -3, 1. So write your answer in slope-intercept form. We're going to start by writing it in a point slope form. One thing we're missing for either forms is our slope, so we need to find that using our average rate of change equation. So m is going to equal our y2 minus y1 over x2 minus x1. And our y2 is actually going to be our 2, because if you look at a graph, we're going to have -3, 1, right? Somewhere over here. Then if we had 6, 2, it's going to be over here, so that point's going to come second, so we want to work our way up to it. So 2 minus 1 over 6 minus a -3. It's going to leave our numerator with 2 minus 1 of 1, and 6 minus a -3 is going to leave us with a 9, so our slope's going to be 1/9. Writing this in point slope form, we're going to just pick one of our points to use for our y minus our y we know is equal to our m times x minus x that we know. It's a point, right? So y minus, I'm going to choose the -3, 1. Just looks a little easier. You can use either one of them. So y minus 1 is equal to our slope of 1/9 times x minus a -3. So move over our 1 and simplify inside of our parentheses. We're going to have y is equal to 1/9 times x minus plus 3 plus 1. So we're going to have y is equal to 1/9. And distribute that 1/9 to the x and the 3. So 1/9 x plus 3 over 9 plus 1. That 3 over 9 is going to simplify down to 1/3. So I want to add these together. Just make this one a 3 over 3. So I guess with y is equal to 1/9 x plus 1/3 plus 3 over 3 is going to be 4 over 3. That's going to be our equation passing through the point 6, 2 and -3, 1, written in slope-intercept form.
Determine if the following lines are parallel, perpendicular, or neither. 3x minus 5y equals 10, and 10x plus 6y equals 20. So we're going to put them into slope-intercept form and then compare the slopes. So we're going to do that. This first one, subtract the 3x from both sides, so we'll have -5y is equal to 10 minus 3x, and we'll divide by -5 on both sides. And that will simplify to 3/5 x minus 2. And then we'll do the same thing for the other equation. Start off by subtracting the 10x, so we'll get 20 minus 10x is equal to 6y. And then divide both sides by 6. And simplify, so you get -5/3 x plus 20 over 6. Then we compare the slopes. 3/5 and -5/3 are negative reciprocals, so it is perpendicular. The next set, part B, we have 3y equals 2x minus 5 and -4x plus 6y equals 6. We're going to do the same thing. This one we're just going to divide both sides by 3, so you'll get 2 over 3x minus 5/3. And this one will add the -4x, or add 4x to both sides. Then we'll divide by 6. And simplify, we'll get 2/3 x plus 1. When we compare the two slopes, they're the exact same, so they are parallel. The last one, x minus y equals 3, and x plus 3y equals 9. Again, we'll put in slope and intercept form. Subtract off the x from both sides. Negative y is equal to 3 minus x. Divide both sides by -1. We'll get x minus 3. And the same thing with the second one. Subtract x from both sides, so we get 3y is equal to 9 minus x. Divide both sides by 3. And simplify. Get -1/3 x plus 3. And whenever we compare them, they're not the same, and they are not negative reciprocals of each other, so it is neither. Write an equation in slope-intercept form of a line that passes through the point 3, -7, and is parallel to the line -2x minus 8y equals -6. So the first thing is to know what the slope of the line that we're trying to make it parallel to. So we'll put that in slope-intercept form. Add 2x to both sides. And then divide both sides by -8. Now we can use that slope -1/4 and the point 3 -7. So we'll use point slope form to start with and manipulate it back to slope intercept because that's what it asks for. So we'll have y minus a -7, which will end up being y plus 7, x -1/4 times the quantity x plus x minus 3. Subtract 7 from this side and distribute. So we get -1/4 x plus 3/4 minus 7, which then should simplify to -1/4 x minus 25/4. Write an equation in slope-intercept form of a line that passes through the point 2, -5, and is perpendicular to -2x minus 8y minus 6. You might notice that that's the exact same function in the previous one, but we'll go through how to solve it from the top. Maybe a slightly different way. See that these are all negative, so 2x plus 8y is equal to 6. 8y is equal to -2x plus 6, and whenever we divide both sides by 8, we'll get -1/4 x plus 3/4. That's the slope, -1/4. And to be perpendicular, you need the negative reciprocal, which would be 4. So we can now do a point slope form again. So y minus a -5 will be y plus 5 is equal to 4x minus 2. We'll subtract off the 5 and then distribute the 4. So we'll get 4x minus 8 minus 5, or y is equal to 4x minus 13. A dance studio has a fixed cost of $1,500 that includes rent, utilities, insurance, and advertising. The studio has a variable cost for each lesson of $35 to pay to the instructor. The studio charges $60 per each private lesson. Write a linear function representing the cost C of x, the cost of the studio C of x, to hold x private lessons for a given month. So C of x is going to equal the fixed costs plus the variable costs. So the fixed cost is 1,500 and the variable cost is 35 per lesson. So where x is the lesson, it would be 1,500 plus 35x. Write a linear revenue function representing the revenue R of x for holding a private lesson for a given month. So R of x is equal to the only money that's coming in is the $60 per lesson, or 60x. Write a linear profit function, P of x, for holding x private lessons per a given month. So P of x will equal the revenue minus the costs. In this case, our R of x minus our C of x. So 60x minus 1,500 plus 35, distribute the negative sign, and we'll get P of x is equal to 25x minus 1,500. Determine the number of private lessons that must be held for the studio to break even for a given month. So that means zero profit. So we can set that equal to 0. 0 is equal to 25x minus 15,000. Add 15,000 to both sides. Divide both sides by 25. And that will equal 60 lessons. And then part E, we'll do P of 82 is equal to 25 times 82 minus 1,500. And P of 82, once we plug that into a calculator, is $550. The table gives RAM capacity and the associated cost. Use the data and regression capabilities of your calculator to find a linear model, round to 2 decimal places. So you go to stat, input your lists, then you also do stat, tab over to calc, and then go down to LINREG, or linreg, or line reg, and that'll be the linear model. So once you put that into your calculator, you'll get a y is equal to 3.64 times your x plus a b of 2.17. And with this, we get an r squared value equal to 0.9868. Where this is very close to 1, it is a good fit. Use the model to predict the cost of 64 gigabytes of RAM capacity. So it'll just replace our x with 64 there, and we'll get that the cost of 64 gigabytes of RAM will be $235.13. 31, identify basic functions from graphs. So this first one looks parabolic, and we can see that it does follow the y equals x squared points. This next one we have pointing down as we go to negative infinity, pointing up as we go to positive infinity. A nice curve. This should be an x cubed. C. We can see as we come from negative infinity and closer to x equals 0, we go down fairly steeply. And then on the other side, as we come from negative infinity up, or down to 0, we're going up, up, up. So that means we have a vertical asymptote. This appears to be a y equals 1 over x graph. D, we have nothing in the negative values, and it almost looks like we have half of a sideways parabola, so that should be a y equals the square root of x, parent function. This next one looks like we just have the x cubed turned on its side, so this will be a y equals the third root of x. This one looks like we have a nice sharp point right there. It bounces off the x-axis. Everything is positive. This is a y equals absolute value of x. Given the basic function y equals x squared, use transformations to the graph transforms to the graph f of x equals the quantity x minus 2 squared plus 3. List the transformations in the order to be applied. So here we'll have shift right 2 units, then shift up three units. So if we start plotting some points, we'll take this, that 0, 0 point, shift it to the right 2 and up 3, up 3. We have this point 1, 1, so move it over 2, up 3. It's kind of this negative 1. Get this idea. Alright, given the graph of x, use transformations applied to each of the following. List the transformations in order for them to be complete. So for the A transformations, shift right 3 units, vertical stretch by factor of 2. So what we do is start taking some known points here. So, for example, this -6, 0 point, and then we'll shift it to the right 3, multiply by a factor of 2, just put a red dot right there at -3. And then looks like there's another starting point here at -7, -2. So shift that to -4 and then stretch it by a factor of 2. So we'll end up being -4, -4. The next point we'll look at is this 0, -4. So shift to the right 3 units, multiply it by 2, end up being right about there. 2, shift it right 3 units, 1, 2, 3, and multiply it by 2, be up here. And lastly, at 6, move it over 3 units, we're at -5, so we'll come all the way down to -10. And that'd be part A. We'll do part B in blue. So horizontal shrink by 1/2. Vertical shift by 3 units. We'll use those same starting points. So at -6, come down to -3, and then we'll go up 3 units. We'll use this -8, -5. So it'll go to -4 when we divide by or multiply by 1/2. Then we were at -5. We'll go up 3 units. This one, 0 times 1/2 is 0. And then we'll go up 3 units. Over here we're at 2. 2 times 1/2 is 1. Then we're vertically at 2, so we'll go up 3 units. And then this last one, we are at 6, -5, so that will go down to 3 in the x, and then up 3 from -5, so up to -2. And then connect all the dots. One thing I should have mentioned from the last one is this has an arrow, this has a dot. So in the transformations, this will keep its arrow even if it gets reflected, and this will keep its dot even if it gets reflected across either axis. Part C. Be a vertical shift, sorry.
Oh, I found her, Isaiah. I think he disappeared.
I have no idea.
He disappeared.
There we go.
He does that.
Vertical stretch.
What just happened?
And then reflect
How did I die?
across
Well, yeah, and tell him, and I'll also shoot an email to her.
axis. Okay, so do stretch by 2, so -2 goes to -4, and then reflect across the x-axis, so it'll be -7, +4. And then this -6, multiply it by 2, reflect across the x-axis, should stay at the same point. 0, -4, multiply by 2 to negative 8, reflect across the x-axis. Then 2, multiply it to 4.
Let me send, Matt, here's this.
So that should go to 2, negative 4. And then the last one, 6, multiplied by 2 is negative, so we'd be at 6, negative 10, reflect it across the x-axis down here. There we go. Whoop. Okay. Last one, D. So this will be reflected across Y axis, then shifted down. So that negative 7, negative 2 will go to 7, negative 2, and then shift down to negative 4. The 6, go positive 6 and then down 2. Then this 0, negative 4 will stay there, but then also shift down to negative 6. We're just 2, 2. We'll go to negative 2, 2, and then shift down, so it'll be negative 2, 0. And then this will be 6, negative 5. We'll go to negative 6, negative 5, and then shift it down 2 units. Alright, given y equals f of x, graph y equals negative 2, f of x minus 2 plus 1. So that'll be horizontal, shift, right 2 units, vertical, stretch by 2, reflect across x axis, vertical, shift 1 unit up. So we'll just pick some convenient points, start applying these, and plot them. So here's a nice one, the negative 4, negative 1. So if we shift it to the right 2 units, we'll be at negative 2, negative 1. Vertical stretch by 2, we'll be at negative 2, negative 2. We'll reflect across the x-axis, so negative 2, positive 2 now. And then a vertical shift up by 1. So it will go to negative 2, positive 3. The next point, we'll pick this -2, +1. So when we shift to the right 2 units, we're at 0, 1, multiply by 2 in the vertical, so 0, 2. Reflect across the x-axis, 0, -2, and then add 1. So we should be at 0, -1 for that point. And we'll do the same thing for here at the 0, 1 point. Shift 2 units to the right, so we'll be at 2, 1. Multiply by 2, we'll be at 2, 2. Reflect across the x-axis to -2. And then shift up by 1, we'll be at 2, -1. And then we'll pick this next point. I don't know, this one looks good. This 2, 3. So if we shift over 2 units to the right, we get 2, 4. Multiply it by the vertical by 2, so we should be at 4, 6. Reflect across the x-axis, 4, -6. And then up by 1, which will be 4, -5. And then we'll connect our dots.